So first I had to make a question, who knows about PRACE? So half of you. So I have one slide about PRACE. So I think that should be enough. So my area of experience is in networking and the security. So what I'm now doing is explain to you the PRACE network and the monitoring issues we have in PRACE. So since the first days, PRACE has offered an internal network connecting the different supercomputer systems via dedicated infrastructure. And in the next slides, I will show you how we set up this and why we have set up this. The session will provide a detailed overview about the current network status, the new infrastructure we are just migrating to, and the transition path, how we do this. Details of monitoring of the infrastructure and setting up of the local environment for the monitoring, and at the end, some details about the PRACE IT security and security policies. That's not going into technical details, it's really an overview about administrative and organizational things. So the original idea for the network, why do we need a network for the supercomputers? Supercomputers stand for their own, they don't need external resources normally, but they need the data to get in. And the idea in 2004 was already the EU project DISA to connect several tier 1 systems throughout Europe. Because we said there are some countries which really can spend money for the supercomputer, but there are other countries in Europe where researchers don't have these facilities. So setting up supercomputers, providing them for the whole researchers in Europe would make sense. And all these days, all the systems have been similar IBM systems. So the idea was, why not connect them by a high-speed network? That if one of the systems is really highly used, and there are a lot of additional jobs, why not send it to another supercomputer system and compute it there? The problem here is, of course, that the data isn't at the other supercomputer system. And there was the idea, because it's all the same systems, we can reroute jobs to the other system and use the data via a global parallel file system. And this time, IBM provided a shared file system with the multi-cluster GPLS, and we tried to set this up. And we started with a 1 gigabit connection, and later on we came to 10 gigabit. So the network requirements, of course, simultaneous reservation of networking, processing, and storage resources leads to increased complexity. You need the supercomputer resources, and at the same time, you also need access to the data, which may be on another system because of this distributed environment. Software interfaces and accounting procedures to request such ad hoc to establish communication paths have been developed. Until then, you need bandwidth on demand. For example, this is today available, but not in the way I would like to have it. For example, I would say I would like to have a 10 gigabit connectivity on Monday morning at 8 o'clock because I need that network. That's not really available. You have it in principle, but a lot of details are not really clear how to solve it. For example, who is allowed to reserve those resources throughout Europe? Who can spend the money? Who is allowed to take this money and really to reserve? So what we saw, what we need is a dedicated network for our infrastructure. That was what we set up. Additional advantage is the dedicated environment without bottleneck identification because of easier reproducibility. If you have a problem, you really know where you have to look for. If you have a shared environment, there may be other users which have used the network. You cannot get the situation you have with your problem once again to test whether there is a problem. And of course, much enhanced IT security because there are no packets from others. You really know what is going on in your network. So one more comment to the DISA consortium. project, as I said, started in 2004, and I think it was going until end of mid of 2009. Connected tier 1 systems, so national systems, and you see here the was Idris, FZA, RCP, Genica, EPCC, CSC, Zara, and ECN, WF. Most of them are also part of the PRACE now. The only one which is this one. So, what was the idea? Just take the open networks of the DISA project and PRACE. And now my slide about PRACE. It's really an overview slide so that you know what I'm talking about. PRACE is the European HPC research infrastructure. So the idea was, so if we have national systems which can be used by researchers, there is a problem. There are problems which are so huge that they cannot be solved on a national supercomputer. It's too expensive. So why not get all the money from the European partners together and buy one big supercomputer, maybe more of them, but some only, which are really big and can really compute huge problems. So that was the idea of PRACE, enabling world-class science through large-scale simulations, providing HPC services for leading-edge capability systems, and those systems are really systems which are comparable to the big supercomputer systems in the US, Japan, China, and so on. With China, we cannot compete. It's too big, but in principle, we want to be in the upper edge to really provide very good resources. We wanted to operate it as a single entity to give access to world-class supercomputers, attract, train, and retain competencies, lead the integration of a highly effective HPC ecosystem, and offering its resources through a single and fair pan-European peer review process with academia and industry. So you just have to ask for supercomputer resources, and there is a committee which looks into your proposal and says, yes, that's was to be computed here. The supercomputers are not only sold, there are 200,000 CPUs, just use it. Those supercomputers are very expensive and they are special, so only applications really fit into the system should get computing resources. That's why we have this remedy.
Yes, politics shouldn't enter into this, right? This politics shouldn't enter into the innovation. I have a question for Cyprus.
Yes, okay. It's really it's a scientific committee which looks into the other resources. So it should be political, but of course anything is political.
I'll leave the question for later.
Yes.
And it's very political, but
yes. So maybe I can answer it, as I said, the networking. Yes, okay, we'll see. So crazy numbers, QD it's 25 members, 400 million total funded by hosting members for PRACE systems and operations. 10.2 billion core hours awarded during this period from 2012 to 394 projects from 38 countries, and you see already it's 25 members, and all these members are not from 25 countries, it's less countries. 25 prototypes of new architecture technologies evaluated, 100 of scientific applications enabled, 50 companies have been supported, and 60 best practice guides and more than 200 white papers have been published. Only that we have an overview of this project. So, now coming to the PRACE network. I think all of you know the GEON network, which is on this ANRADs and all this research centers in Europe, and it's at the end it's the fiber network where which GEON operates. And if we have a more detailed view, it's not only fibers, it's wavelengths of these fibers which are used. And what we did was just asking for some of them, those wavelengths, setting it up as a switch or layer 2, layer 3 router in Frankfurt, using some of those wavelengths, putting switches or routers at the end of those, and connecting the supercomputers. At the end, we didn't connect the sites, we connected some small subnets of the sites where the resources are in. So the grid FTP service, the supercomputers themselves, some monitoring system, but in principle only the resources which are part of PRACE. So that is why it's a dedicated network. We have a net of trust. Here comes the security that we say, for example, HLRS only connects merely systems which are part of PRACE. Not other system of HLRS can use this network. So it's really dedicated, only packets for PRACE goes into this infrastructure. So at the end, that's what we implemented, and you see here it's not the clear state, the red line are those wavelengths. Sometimes, for example, in France, they end at the emblem of France, and then have Ethernet connection to the different partners. Here, we saw after some years that not everyone needs 10 gigabit. Maybe we have an IPsec gateway with 1 gigabit connections, so that you get into this and can connect to the system. So at the end, it's again secure to connect. We know exactly who is connecting here, and it's encrypted. So the net of trust is realized. So afterwards, we saw there are new services which GEON provides. So Bulgaria and Greece connected with a 1 gigabit GEON. We have 2 VPN service. So another step in our infrastructure where we went, and at the end, this is something similar to that what we would set up in the unit. So the authenticated PRACE network characteristics, it's structured as a star topology, net of trust, security policy, it connects small IP networks of PRACE partners where only PRACE systems are connected to, links to traffic are encrypted and are dedicated to PRACE traffic only. So the star topology has a lot of advantages, but also disadvantages. There's a central switch. If it goes down, nothing happens anymore.
No redundancy?
No redundancy. We did this because we said all these supercomputer systems are systems which can work alone. If the switch really breaks down, we can reset it within 4 hours. We go to Frankfurt, set up a new one, and we work again. If the link goes down, okay, we have to see how long the algorithm takes to set up the link again, but the system as its own can work. So it just doesn't compute jobs which need connectivity with others. So it's not a big problem. And the switch didn't go down since 2004. And it's the same switch.
That's because there's no redundancy. They cause problems.
Yes, so it was an easy solution, but as I said, it never in the whole 13 years until the setting up of the switch, we had 3 times that the port went down. So we just changed the port and
And inside the switch, is that your supervisor or something, or that's also?
yes. No, of course, the switch is it's Cisco 6509. I say it's good quality. And we had a 4 hours updated with something equivalent within 4 hours in the hardware problems. So that's a disadvantage. Most sites connected with 10 gigabit wavelength, then it's very good. You can have high speed throughput. Several sites connected with 1 gigabit shared IPsec GRR tunnels. That's good and not, but it depends how much bandwidth you need. If you have a 1 gigabit connectivity and you have to share it with the others, it depends. Maybe you get the whole 1 gigabit if you have fast encryption routers. If you just get a time slot where a lot of others also communicate, you don't have much throughput, but you have connectivity. Okay, that's the advantages and disadvantages. So in the meantime, GEON provided a new service, the multi-domain virtual private network service. And what does it provide? It provides private high bandwidth international connectivity for research and education partners, and provides provides with the combined Android and Xeon network, building a true multi-domain MPLS VPN. At the end, it's what we need on a virtualized basis. It's the same infrastructure as the normal IP traffic for academic users. At the end, it's the same links, it's the same routers which they use, but it's virtualized. It's designed to be robust, highly scalable, and secure. I should say that it's from the slides from Geo. So I do a little promotion. So, but it describes exactly what they want to provide. Because of logical traffic transformation, firewalls are non-essential, enabling high throughput performance. So it's a dedicated network. You don't need a firewall if you trust the other side. If you don't trust them,
engine. You have to trust the end as well.
yes,
Not to make mistakes. Not to make mistakes, not just.
Not only mistakes, we have to trust the staff members of Geo. Of course, they can look into this. Into the.
Obviously, also if they make a mistake, it can also cause a leak. There doesn't have to be someone hostile here. If someone's not careful, it can also leak.
But that's it's the same for your normal IP traffic. It's the same infrastructure. So and of course you have to trust, but you also have to trust that this is dedicated network. It's a wavelengths, and I don't put all these cables into the switches of Geon. They do that. So they could put in a prism and also with the data. But you have to trust.
No, this isn't wavelength.
But there's a difference.
It's IP based, right?
Yes, but there's a difference.
When you separate the opticals, which has different wavelengths, there's less chance of things going to the wrong place.
No, you just put the fiber out, put in the prism, put in the fiber again, and they can read anything if they want.
Yes, if there's a purpose.
So you have to trust.
Yeah.
You can encrypt your traffic. That's not a problem. And they can read. They can do what they want. But they provide connectivity, a direct connectivity, and if they do anything right, no one can interfere packets from outside. And that's what we want. So, seamless infrastructure, only configuration of end user connections, there's lead time of delivery much shorter. So if we had a dedicated wavelengths, we really had to set up a new link, the fiber, and all these things was dedicated, at least at the end, at the last mile, and so on. Here, it's only a configuration issue, and it's done much faster. So when a site wanted to connect to PRACE, it took 4 hours, 3 months, depending on the site. Here it takes, let's say 1 hour. 1 hour configuration, and send emails, and he's approved to connect, please connect him, someone has to configure and it's working. So, intermediate networks are transparent for end users. So a typical scenario Geon describes, that's exactly what the PRACE infrastructure is. An international corporation where a project wants to connect a number of sites from different physical locations to create a collaborative infrastructure as if they were in the same physical location, same level of security, as all the sites would be in the same location. It's exactly what we want, and it describes the PRACE infrastructure. Service implemented by over 100 European emirates, so in principle, you can have it everywhere. Delivered to end users over a service demarcation point at the edge of the emirates or regional network with the emirates router where the traffic is separated. The kind of delivery to the end users depends on the emirates. There are different kinds of how to set up this, and the emirate decides what is the technical realization at their side. And each emirate determines their local MDVPN pricing policy. That may be a problem. So we always have the problem when we ask if we would like to be connected to the PRACE network, how much does it cost? And it really depends on the emirate. We never had contracts with Geon. We don't know what Geon gets out of this. We only have contracts with the Emirates. And if the Emirates says Geon is so expensive, we have to take the high price. we have to accept this. Of course, we also impact this your local report. So the future PRACE dedicated network. The infrastructure will be set up on the combined genome Emirates backbone provided by VPN between the PRACE partners. We use this MD-VPN service in the future. All partners will be connected by VNet through their normal Emirates connection to this PRACE VPN. And then Emirates, where MD-VPN solutions are not available, I say half of the Emirates already have it. You can connect via an MD-VPN proxy provided by Genome. At the end, you use an IPsec connection to Genome, and then you get into this. That's possible. So then there are two possibilities at the end how you can set up logically, let's say. So the first one is you use your normal internet connection, just sharing this connection and having here at the end the second delay. As the second one is you say, no, I don't want to share it, I want to set up an additional link. Of course, that's more expensive, but you can do that also. For example, to say, I only have here a small bandwidth and don't want to share this PRACE because my users, which are not related to PRACE, should be affected, then you put that out this way. At the end, as you see, it's the same outcome. So the question of costs and benefits.
This goes together with the PRACE 503 project?
Basically.
This goes together with the PRACE 503 project, with the
Yes and no. We started to evaluate this in 2014, and it took a lot of time to get all the partners convinced that made sense, and it took much more time to get all the prices for this. And at the end, the decision was, if it becomes much cheaper, why should we do that? Except we would say we really need the dedicated links because we need the technical. But it isn't the case. We don't need technical. We need the connectivity, we need the security, and if you don't have the capacity here, you can do it this way. So at the end of 2016, the management board of PRACE decided, yes, we go this way. And since then, we are migrating. And the end of migration should be end of this week. So, let me say, a little bit more than half of the PRACE partners have migrated. So I hope a lot of them do it this week. And if they don't do it next week, they don't have connectivity. But as I say, that's not really a problem. They can do the local things until they get good. Migrating is ongoing. Phase 1, Jülich, CSCS, Chinica, and BSC have been connected in advance as a test case. In the meantime of the project, we also there came up a new European project, the Human Brain Project. I don't know if you know about that. The medical project researching on the brain. With two aspects. One is to know how the brain is working to manage diseases. And the other one is, if you know how the brain works, maybe we can construct supercomputers with so low energy consumption. So it's a project over 10 years, and the main supercomputing partners in this project are these four, and those are also PRACE partners, so why not use the PRACE network also? So, we said HPP will start with this network and we'll test it. We set up additional links for that, so we have the PRACE connectivity and additionally this connectivity to VPN and tested that. Phase 2 connectivity with the PRACE VPN for the dedicated network has been established. We have set up 10 gigabit links so that the partners which migrate already can reach the old partners via the network. In phase 3, further PRACE partners migrated, LSN, NIRF, and CSC. In phase 4, so this week it is assumed that remaining partners will migrate to PRACE VPN. We have already 2 or 3 which have migrated since I made the slides. So, phase 4, beginning of May, all dedicated partners will be decommissioned. And I have pictured this in the next slide a little bit. First, the PRACE VPN gateway first, the PRACE network structure. The structure is a full mesh VPN. You can reach each other via this links. Maybe it's not really anyone to anyone, but logically it's anyone to anyone. Of course, we use the PRACE geo infrastructure where maybe the links are shared. So the zero trust security policy is to connect small IP network PRACE partners where only PRACE systems are connected to. There's no change, it's only going from physically to virtual. No default encryption, but dedicated to PRACE traffic. The VPN technology, the links between sites are provided by everyone as you know, fully transparent. So they have 3 VPN, most sites use a connection to the admin shared with non-IP traffic, but use different VLANs. Connection speed depends on partner. It can be up to 100 gigabit. For example, CSCS has 100 gigabit connectivity to their switch MRAN, and they can use this. Other partners may have only 1 gigabit and share this. It depends what they will need. So what we have to see in the future, if, for example, this switch partner which sends so much traffic to a 1 gigabit partner that the shared link cannot be used anymore. I don't think that this will come up, but that could we have to see in the future. And then we may have to press down the PRACE traffic. We can do that on the configuration base.
Very important the Sarah in the group. Sarah sending to South Israel. Just a mark with the links.
So we have to see if this happens, but I don't think so. Especially at the 6 of because the partners don't optimize their network. So you all know if you have a 1 gigabit link and you set up an FTP or an SSH FTP connection, what do you get out? 20, 30, 40 megabytes? Because these systems can't optimize for network systems. They could get 1 gigabit, but they don't. So, if no GM and the DPF access via local environment possible, we can use this GM. So that's the sketch what we have. That's the kill network. We set up this PRACE VPN, realized the own infrastructure. We connected some sites additionally to the normal links. Just see here is it. Here should be a red line. So they have additionally then PRACE BGP announcements. So that we get the connectivity between the old and the new infrastructure. Each partner advertises local networking via BGP to the PRACE VPN, so everyone knows where the other partners are. Any other partner has to accept advertised routes. Local access may be installed on numerous routers, firewalls, if you require IT security in a state. Because of the net of trust, you don't need firewalls, but if you say you need it, of course you can install a firewall at your site. The old central router knows via BGP the routes to not migrate partners during migration phase. So at the end, we have this. We have the connectivity here between the old infrastructure and the new one. And for example, let's say CaSToRC sends packets in here, and retry this with some of the other partners. And you see here now this slide, the new partners which migrated already don't have a link to the old infrastructure anymore. They don't need it because they can access the old infrastructure as it's there. And that's the current situation. So hopefully next week it looks like this. No one needs anymore the old infrastructure, and then we can introduce the old infrastructure. Hopefully. So that's the migration plan. The status of migration it's done with BSC, CSC, CSCS, FCJ, and IIF. CEA just connected yesterday. Egress told me they have migrated. I have to check this. This we will do after the session. They will work on the next say not no connection. And the others we have to see they say no actual info means they contact the endpoints, and I don't know the status. And those are sites which don't need any connection to the PRACE network. They say we have special jobs only on our supercomputer which doesn't interfere with any other PRACE partner we don't need. So our users which compute on our systems just connect from the outside to the system. So that's also a possibility. Connectivity. So if they want to have connectivity, they must do the normal internet. Of course, the supercomputers also have connection to normal internet, not only connected to PRACE. So at the end, it should look like this. Anyone is connected to the PRACE NDVPN. It's a virtual connection, so no links. We see no physical links.
Cloud.
This?
Cloud is a good buzzword today.
Yes. So a little bit about network monitoring. We have a special web server where all the information concerning you cannot just if you want to try, you cannot access it because it's accessible by special IP addresses only. So because we say in 4 days, we shouldn't provide this information, how much is transferred of the different links and how much is the situation of the network to the whole world, only to the partners, and that's an IP tables list where we include all the partners. When they told me we need access to this IP address range, then it's possible. So a lot of network information, how it is connected. Some of them are outdated. I want to update this when we have the new infrastructure. Then we will update this so that everything is correct. Here we have the monitoring part. We have PRACE partition reachability, the performance test matrix. At the end, we do hyperpath transmission with all the partners. We have a round-trip delay matrix here. Performance test time schedules, so that not everyone stands at the same time the hyperpath that doesn't make sense. Contact information, trace route information, and so on. I will go into a little bit more detail.
You don't want to?
I tried it, and at the end, the problem with personnel is that some partners don't allow to have systems inside their environment which is not administrated by their staff. That would mean that every partner would have someone who's who knows about the personnel. So we discussed it a lot. At the end, I set up the system before personnel was available. At the end, it's the same. Yeah, personnel is using the difference is that the personnel starts the server when it uses the remotes or when it needs to test. And with this setup, the server is running. You have to set up this IPAP server and waits the overall connections. Okay? If you look at partition reachability, it's simple. It's just having a list of systems we test and we have a network monitoring station in Unity, which just pings all these sites. So at the end, if the connectivity from Unity to the network would fail, anything would be break. But okay, that's a special case, and then we know it's a connectivity. Here, for example, in this at this time, the CEA Inti wasn't reachable, and CSA wasn't reachable, and RCG wasn't reachable. RCG is the kernel state that they disconnected from the dedicated network and never migrated to the new one, so they cannot be reachable by others. So you just see it's a computer reachable by the network. Of course, you can click here to get more information. How long it has been not reachable and so on. Information about how much is the round trip time. So next one is this IPAP matrix. At the end, you see it looks a lot of red. It should be green anywhere. The problem here is also it's not actual because a lot of systems have changed. They must set up a new HiCurve server. I didn't look into this because I said I will do it after the migration. Then I really will stress that everyone who has to set up it should set up an HiCurve server. And I assume that not every one of these systems will be needed. We have to discuss who really wants to be in this table. I want to have it green, and if someone says I don't want to install it, it shouldn't be in the list. It doesn't make sense to always say it's that. So my initial idea was really to have every system in this list. Every system which is a production system. But there are different reasons why it's a process. Okay. One information what you see here, I assume you cannot see it from far. It's three for every partner. It's three numbers. It's TCP throughput, UDP throughput, and packets lost, percent packets lost. And if you see, for example, if you have a 10 gigabit connection, you only get 50 megabit out of it. It's not optimized. Something has to be tuned. And the problem here is really that it's not easy to optimize because HiCurve works different dependent on the operating system. You really have to stress a lot of parameters. I will get into this later. To adjust buffers, to see how much packet, how big the packet has to be to send to really get optimized numbers. And that's really the problem we network the space with applications. If you set up an application transferring data, it doesn't know about the underneath network. It's not optimized for the network. It's just assuming default behavior. And that's why you don't only get 20 megabit out of an FTP. So you have 10 gigabit connection.
Does the VPN also play a part in this?
Does it begin?
Does the VPN also play a part in this,
in this
optimization for throughput?
Of course, because it's shared.
Not that we
You
share,
have a
it is the maximum.
No, just put the factor is packet size.
Yes, of course.
And the fragmentation.
Yes.
So if you optimize for the sites that don't have VPN, the sites have.
There are a lot of parameters where you can play with, and of course, this VPN itself is also one of the parameters. We have to talk to Jean that they provide Django frames and all the things which have to be optimized, of course. Okay, PRACE network monitoring setup. Special software has to be installed on a monitoring node at each partner site. It can be a login node, compute node, gateway node, or any other kind of a node with a HPC system which has an interface with the PRACE subnet. So I said it must not be the supercomputer which does the algorithm. It could also be a FTP server or a special server. Doesn't matter. You only need one to really say you can get this throughput to the other side from A to B. The software program was PRACE1 client.pl, which uses PRACE1 client conf, HiCurve 3 and FPIN. So at the end, that is a Perl program which just does this robot stuff with us. It starts doing the HiCurve for all partners and providing log information which is displayed within this web page. It creates information about throughput tests, round robin times, and HPC login nodes. HiCurve 3 is a client-server program developed by NRDAST, a modern automatic for measuring maximum TCP and UDP, bandwidth performance. It allows the tuning of various parameters and UDP characteristics. It reports bandwidth, delay, jitter, data graph loss, and you can get it here. The new version. FPIN is similar to the PIN program. It needs secure neighborhood, which uses ICMP at the end. What FPIN does, it sends packets to several IP addresses parallel. So if you would use the ping, you would really send a ping. Let's say 3 ping requests. It takes 3 seconds. And it takes the next side, and so on. It has to wait until the answer comes based on zero, and FP class just sending 20, 50 or whatever packets to those kind of destinations and gets back different time intervals the answers and just say, okay.
Do you check with everything all the time and monitoring the services? Is it otherwise it take a long time to time out for this place?
The amping it really takes.
I know that you use the app for the everything decide whether you are going to sample the site because your post might have long timelines.
What we do, the amping is done every 5 minutes. It's still this amping matrix that I told you before, and additionally, this IPA is done normally once a day. In the morning, where less traffic is from users is done. So it's done in this. You have two kinds of amping. The amping I told you before with this matrix was from my network server just to see if every system is available, and the other amping which is used within this Dynamon client program is really everyone to everyone. That's also this is done massively also. It's done in someone in the morning, and that's what I said. It's scheduled.
By the way, thing is also secure as you would say. Just you mentioned secure views, people might have a security problem with that.
No,
the thing is also secure views. And
the normal thing you don't.
The normal thing is secure.
You don't have to make it secure. You can give it only the permissions to bucket.
I think the normal thing is not secure.
Sorry.
That doesn't matter. It's not a security problem because it's really only I think it's secure DB because you don't want that a normal user sends thousands of packets out to the internet. It's not because of security reasons. You just send out a packet and gets back the answer. That's multi-times. So in the amping, you get that source watch. So at the end, all this information which is collected by this PRACE client program is sent to a monitoring server at the PRACE center at Unix. The aggregated information is archived and accessible via this page I showed you before. Configuration file contains the IP addresses of systems to be tested. The passes where software components can be found. Of course, you need to know in different kinds of systems where the amping is located, and so that has to be configured. The other configuration options, you can really say I need different options to different systems. I told you that depending on the system, you have to change parameters to get optimized values. You have to play a little bit with these options to get really the best output. And the IP address of the monitoring server, of course, because it has to send the information to this. The PRACE client conf must be adapted to local environment. To get optimal performance, IP function must be adjusted. So now coming to the optimization of the network throughput, and here you see the preferred PRACE network options. And that's unfortunately I cannot give a list of options to set. I only can give a list of options where to look, because I said it depends on the operating system, and it depends also on the version of the operating system. Maybe you have found an optimized scenario for all the other partners, and then you upgrade to the new version of your operating system, and nothing fits anymore.
Switch used to run an NTT server, which gave recommendations. The next update is still they started giving it service for some reason.
Yes, the main problem is it's a lot of work to do. Because it really is operating dependent, it's dependent on your network card, it's a lot of parameters.
Yes, but basic things will give you a throughput, will give you recommendations, point out the bottlenecks.
So the recommendation I can give is look into these options. It's the IPQ maximum, the RFC, the 1323 RFC 2440, that's really related to how TCP should be set up, secure selective acknowledgements, the socket buffer maximum, the TCP ECL, I don't know what it stands for.
Early congestion.
And TCP message default, TCP new Reno, that you use newer TCP stack, TCP no delay acknowledgement, TCP and UDP pass and discovery should be used, and TCP UDP send and receive space should be set accordingly.
One thing people oftentimes realize in NTU, because of the certain error rate, the maximum TCP rate is linear compared to the NTU. Even if all the TCP settings are okay.
So it's a huge area where you really can look into, and optimizing one parameter can lead to the fact that another one gets worse. So why are those important? Especially when it's delay drawback, as is one of the reasons. It determines the amount of data that can be in transit in the network, drawback of the available bandwidth, and the latency. Here's an example. For example, if you want to communicate from Frankfurt to, I think it was the US, it's 6,211 kilometers, and if you know a signal within a wavelength needs can transit 200 kilometers within one millisecond. It's easy to compute. If you have a 10 gigabit connection and round trip time, so 2 times the 6,000 kilometers divided by 200 kilometers per millisecond gives you 1.2.5 megabyte per millisecond. It's just this computed, and multiplied with 62 milliseconds. So it's 79 megabyte buffer per packet you send. Per connection you set up. So the problem we see here is if you have a supercomputer with thousands of users doing connections, you cannot provide 1,000 times 80 megabyte buffer. And you don't need it because the 1,000 people don't all communicate to the US. They all communicate just to their partner, and then it's 1 meter, not 6,000 kilometers. So here you already see the problem setting up the network or optimizing the network isn't easy to do. So the next one is path-2 discovery. Don't fragment packets. If you fragment packets, or if you send a big packet and it has to be fragmented, at the end there will be several packets which have to put together again. This is work to be done, and that also leads to degrade the packets. And of course, using jumbo frames makes packets as large as possible. Normally, Ethernet has about 1,500 byte per packet, and if you use jumbo frames, it's 9,000, so it's 6 times. So you have 6 times, not the packet header to include. Makes it possible. The disadvantage is, of course, if the jumbo frame gets destroyed, you have to send 9,000 bytes again. So that's
if there's a high error rate, actually the Java frame will still improve performance.
okay. Now we have this trace route P. At the end, it looks like this. Those are the systems, the production systems, and we just check if the connectivity to this site is possible. We have here the monitoring server. At the end, what we are doing, we do a trace route via this to, for example, Queen, trace route from this to this systems, and then so just to check if the path is available. And here, for example, those two systems are not available because they are currently in production stop. And here you see it's no IP defined. I don't know that the keyword local or out IP addresses because of the transition. I have to check this. Later on, NC should be green. Those are the partners which are purely the old infrastructure. CEA already got in the top. So hopefully this will be zero next week. And of course, we also have partners which are not connected, not using the PRACE infrastructure, but they can also be reached via the normal IP network. And underneath on the page, you see the trace route information. Ping-R doing including all the hosts which are traversed when you send the ping to the end host, and do the trace route, and you see which hosts are traversed. So just to see if it's the right connection. So monitoring and KPIs, network monitoring has been ported to the new infrastructure. Currently all net info on spatial web server, but XML files could be provided for sample monitoring, so that you don't need to go to the server, you just go to the sample monitoring server in Kenya and get all the information. We haven't done this yet. We have an offering by Geont to provide a Geont PRACE VPN monitoring solution based on personnel, and here we have again to check maybe possible to set up personnel nodes at all partners, and it also depends on how much this offering will cost for PRACE. So discussions have not yet started with PRACE operations. The pros, of course, we have less work to do. You don't have to set up the servers. It's done by Geont. And the disadvantage, of course, it's external equipment within the PRACE infrastructure. It is additional cost and coordination and integration over that. We will also have. We will have to see. It's not decided. So now I end with networking. I want to give a little bit overview about the PRACE security model. PRACE is structured into several tasks, and you see here, we started in 2004 with first the thought about PRACE, and we had the PRACE preparatory phase, and since 2010 we have this PRACE implementation projects, starting with 1 IP, we are now just started 5 IP. The PRACE is structured into several tasks, and the operation is done in work package 6, services for the HPC ecosystem is included here, operation and coordination of the comprehensive common PRACE operation service, including the PRACE networking and security. And we will have links with other infrastructures and COEs also in this work package. And especially we have connections to the Human Brain Project, to ULAT, to SCI, which is Security Incorporated Environments, which now is WISE. It's a WISE community. It's a lot of security persons which think that within cooperative environments you have to think about additional security issues. For example, the US organization has a security policy, and you want to cooperate with others. For example, in PRACE, we have to trust each other. So what we need to know, let's say Jülich needs to know that Cyprus Institute is also doing good security. They have a security policy, they look into things, they have a security operational team, and so all those things. And of course, you may not will to provide so much information. You don't want to exactly say how your firewall rules are set up. But maybe it isn't enough for Jülich that we know that Cyprus has a firewall and that someone other has looked into it and has said, yes, it's okay what they configured. An independent rating or whatever. So there are different kinds of cooperation you can do, and depending on the cooperation, you need different kinds of security levels you have to know about the others.
I think this is a good time for the security question.
Yes.
It has to be critical. I'm the user who was got his PRACE in front and last time the security officer is okay. And once he got that was the all networks in development in secure safety. And they say it's important someone Europe will reliably do that a lot. They will authorize connection. And Israel is a member of PRACE.
Yes.
And actually went up to the chair and he gave instructions to allow it, and they still being got denied again afterwards. First we thought it was okay, and it was very, I think it's unprofessional. No, but someone who knows the PRACE security model, there isn't a technical reason to
maybe I really cannot. I'm not.
I'm sorry.
I'm not involved in this, but of course there are several sites have rules who is allowed to use a supercomputers. There is a special list of, I don't know how it's called, but special countries are not allowed to work on the supercomputers, for example, or persons from special countries. So I don't know. I don't know if all PRACE members have the same list.
Definitely not. I think it's a nation. It's defined on a national level. So if there is some, let's say, official European Union list, then I think you are not even obliged to really comply with it. So usually the countries try to comply with it, but they might have their own stricter rules.
So for example, I could assume that someone asks for CPU cycles at a special system, for example, and this team looking into the research goodness of
the research was approved by the scientific community.
Yes. Those don't look into nationalities. They only look into research. And maybe they say, okay, that's fine. That absolutely fits into the ULI supercomputer. And then afterwards, the ULI people say, but this person is not allowed because of our rules. That could be, I don't know.
Yeah.
As I said, I'm not involved.
Actually, there might be third level, which is the vendor. Because in the past, like
In our case, it was a vendor.
Okay.
Yeah, I had a problem that well, we had a student, some PhD student at our university, and he wanted to access our volleyball in the 2003 or something like that. So it's a long history, right? Now, not that ago, but there was a student coming from Iraq, and he was studying at our university. It was perfectly fine. And when he wanted to access our at that time IBM SGI machines from the US. So we had in the contract that we had to follow the current export policy of the US and allowance. So I really had to check the web page of, I don't know which department of whatever in the US, better knowledge of this. And I really found out that at that time Iraq was prohibited. So I said, I'm sorry, but I cannot create an account and let you access the system. And that was because of the contract we had with the vendor. Yes, that's completely independent from the national security policy.
This is the first of Canadian citizenship, which is also been said.
We also have imposed restrictions. We have to follow the US export restrictions because of the system provided by IBM. It doesn't include yes, of course. But we did have to define user, not only on where they came from, but also the nature of the research. It was going to be
So at the end, to get back to IT security, this person gets an account on the ULI system, for example. The security, IT security is okay. That's maybe a political one if he gets an account, if he gets access to the system. But that's not IT security, that's a political decision. It's maybe not good for PRACE if such things happen. You could check this in advance when you say you get CPU cycle, but that's the manager. A problem from the management. Let's say it this way.
No, I didn't imply you should fix the problem. just trying to understand. I was just trying to understand, since you're on the question, why did it happen?
At the end, coming back to security policy, of course, if, let's say Cyprus would say, we allow everyone to access our systems without any password. That would be a security problem. That would distract the net of trust. And then we could say, okay, we accept this, that any partner has to accept this, or we could say, no, that's not possible, Cyprus cannot be partner of PRACE. That could be a decision by the management board.
Were you trying to connect to the PRACE network or to public internet?
Not public internet.
Doesn't matter whether it's Emma or the Region or the PRACE network.
Georgiana, it's not the president at the time. The person who got approval to run those. And it wasn't you need to improve something, was we then authorize it. And if you guys were in Sweden, well, inside Europe, it's okay.
No, there are people who block entire countries. I mean, if I'm getting a connection from, I don't want to say the areas, right? I don't expect any users from there, so I block the whole country because, you know, my nodes are flooded. I'm not talking about specific one, but this happens. You see, don't get connections from Russia, I'm gonna, you know, because I don't get any users. I go Russia. Yeah.
Anyway, it doesn't depend on the type of membership of PRACE. It's not only, there are different types of membership and you're allowed to do different things or consume some amount of CPU cycles or whatever, it depends on the membership. So I don't know what is the case. It's also can be an issue that you can be rejected because you are not on the at least the minimum membership you have.
Because and it's connected to the chairman of PRACE, and the chairman of PRACE said it was okay. So I don't think that could be used as an excuse.
It's not an IT security problem, it's
Okay,
management problem. So, okay, links to RFE, as I said, you went to view that SCI wise, the ARC project, EGI, EU, PRMA, and of course, Geon. So Geon is it's the company providing the network, and it's also in the new project. So why are network and security correlated? A dedicated network allows to define different security policies to be used than public networks would allow. No interfering with traffic, no spying for hackers. So what we need is this net of trust. Here comes in the work which is done in the WISE community. So we have a PRACE security forum. It defines its security-related policy and procedures to build a trust model that allows integration of distributed PRACE services. The risk review of new services or service upgrades to define and maintain an agreed list of software protocols that are considered robust and secure enough to fulfill the minimum security requirements. For example, if we like to set up a new service, we check if this is secure enough to be used in the PRACE environment. And this kind of problem started the idea of security within in PRACE already in DISA, project before, where someone said, oh, we want to set up this kind of software. The problem is on our system only, and I said it cannot be. You are connected to each other, and if you are using this kind of insecure software, you cannot be part of the data network. And it's our own decision and so on. And we said we have to set up this forum where we really discuss those things, where we decide is it secure or not, and then depending on that, the management board has to do a decision. So the management of operational security, of course, also part of the security forum to coordinate incident handling with CSI team. So and that's the organizational structure. Any site has its own security team. It sends in IT security representative to the forum. We have a security forum coordinator, which talks to the management board, and the same is within the operational environment. Of course, every supercomputer has its a whole operational team with members of the team which sit here together. We have an operations leader, that's the leader at the end of the work package 6. We also talk to the management board, and of course here operational policies have to be exchanged. Is it allowed to use the service? We have a new service, we can check it and so on. So all partners provide members to the PRACE CaSToRC team. Site incidents must be reported in case of possible impacts on sites. Of course, that's a problem. It's really local and doesn't have any impact. It doesn't need to be announced to the others, but if it's something which could others affect each other. Vulnerability reports have to be provided, no formal documents, any available sources for information can be used, stored in the PRACE wiki, chain of emergency phone numbers and security mailing lists for all sites, and we know who to contact if there is a security incident. Although every partner is expected to have already informed information about vulnerabilities in general, it is helpful if specific information is also provided through internal channels. For example, if you get information that there is a problem with some software components, you could send it to the firm to inform all the others, maybe they have not this information. Especially if you know that others have the same software components implemented. Let's say GPFF or
It depends to get the latest from the policy. It depends. A lot of security vulnerabilities are given, and you're not allowed to be distributed.
Yes, it depends. And I come to this later. So security policies and procedures, minimal security requirements that all PRACE sites are expected to abide to, agreed list of software protocols that are considered robust and secure enough to provide these services, trust model that allows smooth interop of the distributed PRACE services, the policy that address the risk review of changes in the infrastructure, the handling of security incidents, the auditing of security setup, the roles and responsibilities of personal teams. We also have risk reviews. The security firm performs a risk assessment of new services or updates on existing services if changes in security setup come up. Prerequisites here are provision of security policy documents by every site, and possible self-assessment using a document published by the SCI group now the advice group. That again here, of course, not everyone wants to provide all the information, but we need a special level of information that you have that you secure your system in a way that you have good passwords or keys or whatever. So this is information we need. So collaboration on security with other projects and activities mostly handled in work package 6.3, which is led by Stefan, who is in the other track of this meeting. We have collaborations with EGI, new brain projects, the EU to CaSToRC by sharing information on incident and vulnerabilities, enables exchange of information about incidents if there may be cross-domain impacts, and also exchange of vulnerability information. Several PRACE colleagues are from EGI, EU and HPP security alert list and vice versa, so we really interact there a lot and exchange all the information which is needed. So coming back to your question, we plan to be part of the Trusted User Program, which is a service from Geon. You can register your team there, or let's say there's 3 stages. You can list them, which provides basic information about the team itself, as well as shows endorsement of the team by the TI community. You can be accredited, which ensures a defined level of best practices and acceptance of the established TI policies for such teams. And you can be certified if they have been accredited before and prove a confirmed level of maturity as defined by the TI framework. We want to be accredited. Certified is a lot more work, and we don't think we need it. And accredited really means you get much more information about incidents, about vulnerabilities, which normally have the levels green, amber, and so on. And here you get much more information because they know you do good work with security, and you are worth to get this information. So what really means accredited for the teams, access for listed teams is self-service interface for updating information, access to in-depth operational data of all accredited and certified teams, restricted and encrypted mailing lists, as well as restricted but not encrypted mailing lists for administrative purpose and open discussions, attending events like meetings and trainings. Members can attend the open TFC meetings and closed TI meetings. Secure our band alerting system, restricted and protected alerting services using state-of-the-art mobile communication, as well as traditional telephone communications are operated to provide crisis communication independent of the internet. And what you can additionally secure IRC server, restricted and protected IRC-based discussions to enable real-time collaboration on burning issues, public key infrastructure, member teams will be updated, as well as individual team members getting extra online certificates in order to gain access to restricted and protected services and interfaces. That's what I just talked about. You can download CSV files with contact information about all teams registered by the TI, including accredited and certified teams. In addition to GPG, PGP key links are made available, and there is a TI compendium quick orientation of teams and such useful reviews illustrating subject of teams. So that's about the accreditation. And one more slide about the PRA, it's a European Policy Management Authority for Grid Authentication. PRACE trusts the CA, it's accredited by EU and PMA. The other two PMA generated in the IGTF and the Interoperable Global Trust Federation. PRACE is also relying partner of the EU and PMA, and those teams meet 3 times a year at a face-to-face meeting, and this is attended regularly by PRACE representatives. And last but not least, general principles. Each PRACE site is responsible for the management of its own users. User registration or certification methods may slightly differ from site to site. The PRACE accepted use policy applies to all users of PRACE. Some sites may have also specific regulations related to security, and this is exactly what you just mentioned. So there's a general concept, but there may be special regulations on the system. The PRACE security model has been in production for now more than 10 years and proven to fully fulfill the security objectives related to the PRACE needs. PRACE is following closely the identity configuration initiatives, and interoperability with other project communities and industry is the main goal. I must say the security model was good for the last 10 years, but maybe there was no real attack. That's always with security and insurances. That's it. Yes. Any questions? Coffee break. If there are no questions, thank you for listening. I assume that
we get the